Welcome to the meeting where we present the use cases and functional requirements for an extension of one of the first standards called the MPAI-AIF framework. This is the version 2 of the standard. One slide about the MPAI. MPAI has learned from the success of standard in digital media and wants to repeat the same story with AI-based data coding standards. Data coding is, for us, the transformation of data from a format into another format that is more suitable for an application. So we don't consider, in general, monolithic AI solutions. We consider solutions that can be broken up in components that we call the AI modules, and they are defined by their function and by their input and output data. AI modules are organized in the workflows, and they are defined by their function, their I/O data, and the topology of connections of the AI modules. AI workflows are executed in MPAI specified environments called AIF, and they are specified by metadata and APIs. So this is a very simple description of what is an AI module. So it's something that takes data input and provides the data and does a certain function, in this case, a speech analysis. This is an example of AI workflow embedded in AI framework. And what have we done so far? We have developed 5 standards. One of them is the AI framework version 1. And we are about to start another 3 projects. 2 are continuation of existing projects, the AI framework and the multimodal conversation. And 1 is entirely new, which is neural network watermark. So a few slides about how we have applied this approach, this component-based approach, in a few cases that exist in version 1 of standards. One is how can you generate an utterance that has a certain type of emotion, but starting from an emotionless speech segment. Or how can you start from an emotional speech segment and say, I want to add anger? Of course, you have to have semantics of anger. And so this is an example of how this can be implemented with the version 1 of our standards. Here we have conversation with emotion. So we have a human speaking, and the machine can see the human. So there's speech recognition, language understanding, extraction of emotion from text to speech and video, fusion of emotion, dialogue processing, and then a speech synthesis and animation of an avatar. This is quite simplified. This is another example, company performance prediction. So you have a company, you have plenty of data. You process the data according to these 3 AI modules. Then you use the governance features and the financial features, which are specified in the standard, to predict the probability of defaults in a certain time frame and an index of validity of the organizational model. So this is what we have done. What do we plan to do? So I'll give you just a few examples of what we plan. The first one is personal status extraction. So this is kind of a composite AI modules. It's composite in the sense that it contains 9 modules inside, each with certain features. The first layer produces descriptors. The second layer interprets the description. And the third, which is just an AIM, fuses all of this data into a format that is called personal status, for which we are calling for proposals. What is personal status is three characteristics: emotion, cognitive state, and attitude. Emotion, well, I suppose you know. Cognitive state is more rational. So it is what cognitive state is after having interacting with a person or with the outside world, and the attitude is your stance in vis-a-vis the world in the future. This is another example, is the personal status display. So you have assumed that you have a machine and you have created a personal status machine, which is entirely virtual, I agree, but you can use the text, what the machine wants to say, the personal speech, the personal space, and the personal gesture, and you will see an avatar that is speaking and has a certain face that is congruent with the personal status of face, and a certain gesture which is congruent with the personal status of gesture. One last example is the connected autonomous vehicle. This is the case when a human interacts with a vehicle. So you see a large number of AIMs here. One is the audio scene description, is another the visual scene description. You see here a personal status extractor, and here you see this time is language understanding, question and dialogue processing, and here we reuse this personal status display AIM. Well, I was wrong, because there's one last one, which is the virtual secretary. And the virtual secretary is in the sense that it collects what is being said at the meeting and uses this summarization AIM and produces a summary which is displayed to the avatars, and the avatars can comment, and the virtual secretary can refine the summary and produce an edited summary. So this stops my introduction, and all the floor is to Andrea, please.
Okay,
Andrea, by the way, is the chair of the AIFv2 development committee, which has produced the first version and will produce also version 2. Please, Andrea.
Right. Thank you very much. Thank you very much, Leonardo. Okay, so I just want to come back again on the concept of AI framework. Leonardo already sketched, what is the vision of MPAI is the fact to enable multiple technology vendors and providers to offer their component that can be easily assembled in a larger project, in a larger application, and can be quickly prototyped, brought to market, and so on. We want also, to help user to have better application, because they may have the option, in fact, of selecting the individual component of the application. The updates of the overall system, even if it's very complex, would be much easier. So there are a variety of good reasons for a framework. Of course, developing a framework, the idea is, I think its sound is good, is not new. A lot tried to create frameworks for software to simplify the development and deployment process. But for AI, it's even more complex, because in addition to the traditional software issues that need to be discussed, so typically, compatibility among the different components and interoperability, we have all the AI functionality that need to be taken care of. But despite the fact that it's a daunting task, we decided to undertake it. We can move to the next one, Leonardo. Okay, so first of all, we made a clear choice in the standardization process. What we standardize are interfaces. Maybe Leonardo, if you can continue so that they can get the full picture of what they have. You see these black thin lines that are among the boxes. These are the interfaces. This is the part we decide to standardize. So, you know, we don't standardize what is inside an AI module, but we standardize its interface so that it will be easy to connect a given AI module to all the other modules. Same thing, you know, for storage functions or access functions or global storage or communication. We really and the user agent. We really focus on APIs here, so that we give complete freedom to the implementers and to the innovators actually to produce AI modules that are you know, sophisticated and performant. So the first question that we had to answer is if we create a framework, what are the basic functionalities that we want to offer in this framework? And you see the different blocks actually represent what we identified. Well, first of all, the modules, right, that represent complex functions that are encapsulated in a single container that exposes an interface, and so that they can be combined like Lego blocks together to create complex functions. And to these modules, of course, we need to give several functionality. We should be able to allow them to store content and, you know, in different modalities to provide some local storage, you know, fast storage, so an interface to something that the modules can use, and also, you know, storage that can be shared among modules. We wanted to provide also an orchestrator, a controller that is able to, you know, put together these AI blocks so that they can perform a given function and control them. So how this complex function can be started, can be stopped, can be paused, can be interrogated in terms of status. And typically, you know, an aggregation of IAMs in MPAI-AIF is called a workflow, is what is indicated here as AIW. And you know, a given controller can control multiple IWs. Here you see a very schematic representation, but you know, this can be completely distributed. So the way in which we addressed the framework is to be very flexible, so that it could run on very simple MCUs, as the first implementation actually did, but also to complex distributed systems, where, you know, an AI module can be a large server or a group of servers located somewhere on the planet and then connected over, you know, over a fast network with the rest of the framework. So I said the controller has these capabilities. We provide also, you know, communication in interfaces, so that the IF can talk with the rest of the world, as well as access to global storage that has different characteristics than the local storage that is mainly for individual IAMs and for, you know, sharing local information in the framework, but, you know, much larger storage, which you know, there are no limitation, in fact, on the amount of storage that you have, and can be distributed, you know, with its own OS and something like that. Then we provide a function of access. What we call access is really, maybe Leonardo, you can move to us on the next slide, in which actually all these concepts are a bit articulated. And, you know, access provide access to static or slow changing data, domain data, data models, and so on. So something that is required by the framework to properly work, but is not, that does have the characteristic of, for example, the local, you know, the local or the internal storage. And then, you know, the overall framework has a concept that we got used to, you know, the concept of store. very similar to what you're used to do with the current application stores for the main OSs. So why the store? For many reasons. First of all, because through the store, we're able to offer a given level of security and validation of the different IAMs, of the different workflows, so that it can be the very first point in which we guarantee quality, security, performance. I don't get in detail on the MPAI store, but there are a lot of notions behind that allow a developer to actually upload a given given IAM, but also validated, certified, I would say, double quotes, by MPAI, so that when it gets used in an application, it will perform as expected. And then, of course, talking about modularity, we needed to have also an interface that allow the AIF to be controlled also by external entity. And this is what we call the user agent. So we defined an API that allow to have high-level control of the AIF and also high-level visibility, so that we really partition the details of the framework, so that the inner details of control details are part of the controller, but the user also can have a high-level view as well as a detailed view in a very scalable way. Okay, so these are the basic AIF components. I think we can move to the next slide. And as I said, again, it's we defined the three APIs for this that were mentioned in a previous slide. So what are the key features from a technical perspective? First of all, we wanted to support both software-based architecture and mixed software and hardware architectures, and for this we actually have support for both event-based architecture that are the most common in software implementation, but also port and channel-based interfaces, because this is a typical approach that is followed in hardware or mixed hardware and software. Imagine that you have an FPGA, you have an NPU, network processing unit, that requires that you actually control it through an SPI interface, I2C interface, something extremely low level, and also without the possibility of actually having a complex software interface and a given number of signals that go to this unit. So we decided actually to cover both. From an event perspective, we separate two classes of messages: the high priority messages that are system-wide and allow global actions, and then messages that are exchanged for the different functions implemented among the IAMs. And again, the concept of messages is common between the channel and port approach and the event approach, so that we have a uniform view of a system, even if it's mixed, and so it's much easier to manage. Then I said, we really wanted to have a wide range of a system that could implement AIF. So the AIF can be fully distributed. You can have the controller running on one machine and having all the IAMs running in different machines connected over a network, implementing a given IW. So full distribution. And we are thinking about introducing profiles. Currently, we don't have profile in the spec, but we may consider them in the future. The controller component is always present, and the reason why this is happening is because this reduces quite a bit the dependencies of the underlying OS, because you know, we provide an overlay messaging system, again through events and port and channels, and it's very lightweight, and this allow us to you know, to be compatible with a lot of OSs that go from you know, RTOS, real-time operating system, Zephyr, up to Linux and distributed OSs. So because we have this this overlay. And again, another important feature, we want to have the AIF to be as dynamic as possible, so the different modules are hot pluggable, and that allow us to, you know, to have the system adapting actually to external conditions and activating and deactivating modules as needed. Okay, next one. Okay, so, you know, I already mentioned that our target, you know, for version 1 was really, you know, to have multiple technology providers, of course, with potentially different security requirements, as well as, you know, multiple users. In AIFv1, so the version 1, we made the assumption to always run in a trusted zone. Where, you know, the notion of trusted zone was a bit left to the implementer. We specified a high level, but we realized that we need to provide much more details and much more specification, because security, as you all know, is becoming more and more relevant from very simple you know, MCU architectures to complex systems. And so, you know, we decided to start AIFv2 focusing on security, so providing a secure infrastructure. And this is the reason why we have this call for technology. Of course, yeah, next slide, please. Okay, so this is how we thought about security. Okay, Leonardo, if you click on, then the magic button will appear. Of course, you know, offering trusted services to the architecture. You know, so some of you that are familiar with security probably recognize traditional security services provided, you know, by the frameworks, like you know, the attestation service, you know, secure communication, secure storage, and you know, and the crypto engine that is a key element for that. We wanted to do a step further, in which, you know, we identified also specific security services that are really that simplify the life of developers of MPAI-AIF. So we can move to the next slide. Right. Okay. So these are, you know, these are the basic services that I was mentioning before. So the encryption services, the attestation services, the trusted communication services, the root of trust. So all the parts related to secure boot and so on. But next one. But in addition, you know, we wanted to simplify life of developers, so that provide secure services for the macro component that we have inside the AIF. Think about an IAM, right? The AI module. The AI module has requirements in terms of, you know, secure storage, of course, because it has to, you know, to store data. That then get present. This data may need to be secured as much as possible. If it has an AI component, it's very likely it has also an AI model. So we need to provide functionality that allow the IM and the AIF actually to validate that it's the actual model that need to be used, and the IM has the rights actually to use that model. And this is what we call model validation. Models in machine learning, need to update it, in particular at the very beginning of the life cycle, quite often, because then there are updates to just avoid the model shift, actually, so that it can keep producing the correct inferences and quality inferences. And so this is also an important functionality that we want to offer, the possibility of enabling the IMs, enable the AIF to do secure model update. And so many we define this these three categories of services for really the modules of the IF. So in terms of storage, of course, the possibility of storing models, even large models that may not fit necessarily the local memory, but need to access a flash, you need to access an external memory device. But from a programmer, from a developer perspective, should be quite transparent, not to move from secure non-secure. Not should be easy. It should be easy to program. With security, it's always complex, because if you make a mistake, then you're dead, because the system can simply lock in, and then you can't do anything else. We want really to simplify the different tasks on the storage side, on the communication, and on the specific components of the AI. So encryption of the model, signature of the model, and watermarking. And Leonardo already mentioned some of the activities that we are doing in MPAI with respect to this. Okay, next slide. Okay, now this is another concept that that we introduced in MPAI, and it is the fact that given that we have a lot of different users and technology producers, we wanted to go beyond the concept of level. Simply because there is a lot of legacy components, and some of them may be limited in hardware, so they don't have the possibility of offering complex security services, but they can offer some of them, and we are in a transition. And this transition may be relatively long. So we wanted to offer, in addition to levels of security, that is what probably will be on the medium long term, also the possibility of define different, we call them a regime, security regime, in which the developer itself may pick and choose different combinations of security of some component or some other component, because maybe it is not needed, or maybe the model that is used is an open source model or public model, so there's no reason for protecting it. While we need to save resources, so we wanted to give the maximum flexibility on security, not only simplify the use of security, but also give the maximum flexibility. So we introduced this concept of security regimes in which the developer can pick and choose. Of course, making this choice will influence the compatibility with the other models, because from a security perspective, you need to have a base level of security. So some modules that offer some level of security may be used in some context, but not used in other contexts. But on the other side, we don't want to impose everyone a level of security that they may not be able to offer immediately. Okay, next one. Okay, of course, and this is the last point we're gonna discuss. We want to make sure that these trusted services really integrate well with current OS infrastructures, and both from a hardware and software perspective. So we don't want to reinvent the wheel or impose constraints that do not make sense. So we want to reuse at the maximum all the resources from a security perspective that are available, from the OS perspective, from the hardware perspective, from the software perspective. And so the integration of the services that we want to offer with the existing component, it is very, very, very important, because again, we really want to democratize AI, allowing a combination of different modules, secure modules at this point, in the easiest way. So without this ease of integration, then this will become an issue. And then finally, AIF is, as I mentioned before, it's very flexible, very dynamic, and includes actually a configuration, a JSON-based configuration that is loaded at the beginning, that allow to configure the different IAMs, to connect them together, and so on. And of course, all the security information will be reflected in the current JSON metadata that define the AIF. So these are another requirement that we have. Next one. Okay, so next steps. We're gonna publish on July 19th the call for technology. On this, focus on version 2 on security, with the kind of requirement that I outlined in the presentation. On September, mid-September, then we'll get notification. So you have to notify, in fact, if you plan to submit a proposal. And by October 10, the proposal need to be submitted. They will be evaluated, so we'll start immediately with the evaluation. The kickoff is October 12, and then by spring 2023, the plan is to have a V2 specification that includes all the security components. And with this, I think this was the last slide, Leonardo. So I thank you very much. I hope I've been clear enough on what we are trying to accomplish here, and I would say I've opened the floor. So if you have questions, I'm more than happy to, together with Leonardo, to answer to your questions.